Okay, section B. Question number 10. Maximum mark 16. Suruscary and Rockall are a small island in the Atlantic Ocean in the same time zone. On a given day, the height of the water in meters in Suruscary is modeled by the function of like this. As you see, it's a sinusoidal function with a periodic function, where t is the number of hours after midnight. The following graph shows the height of the water for 15 hours starting at midnight. At low tide, the height of the water is 0.5 meters. Over here it says 0.5 meters. And then high tide, the height of water is 3.76 meters. 3.76 meters. All heights are given the correct 2 decimal places. The length of the time, question number 8, the length of the time between the first low tide and first high tide is 6 hours. So it says from here, okay, from here to there, the length of time here is 6 hours. And the m minutes, okay, 6 hours m minutes. So it says 6 hours plus m minutes. Find the value of m to the nearest integer. Wow. Okay. All we need to draw this function from given domain. So we need to find that function. So but definitely without the calculator we cannot solve this problem. So go to graph and delete everything. I'm gonna draw y2, 1.63 of sine 0.513 open parentheses x, t is x, minus 8.20 close parentheses twice plus 2.13. So in this case we're gonna restrict domain, divide by open parentheses x, second task go to greater than of 0, second task go to logic and x, second task go to test, and then less than 15. Domain is until from 0 to 15, and then we draw this graph. It shows exactly like that function over there. Okay, and then the length of the time between the first low tide and the first high tide 6 hours. So we need to find value of x from the lowest value over here. Here it says x equal 5.1385. You can say 5.14. So point over here, x value right here. So it's 5.14 to x value over here. We can find the graph. Is that right? Shit. So it's 11.3, 11.26 to 11.26, 11.26. So second quit, and then we can 11.26 minus, this is hour, right? 5.14 give us total of 6 hours, 6.12 hours. So the answer is going to be 6.12 hours equal 6 is just subtracted, so 6 hours and 6 hours plus 0.12 hours. This times 60 will give us so it's going to be m to the nearest integer. So it's going to be 6 hours plus 7.2 minutes. So m to the nearest integer will be, the answer will be, should be 7 minutes. 7, right? Okay. B. The between two consecutive high tides determine the length of time in T hours which height of the water is less than 1 meters. Between two consecutive high tides. So between two less than 1 meters. So first high tide is should be summerable here to second high tide summerable here. To find the time in hours for which the height of the water is less than 1 meter. 1 meter line around over here. So find the t value over here and there, right? So all we can do is go to y and then put the y1 to 1 and see how the graph look like. So between two high tide, find the t lengths of, okay, now calculate. So trace over here, find the x value, the x intercept. So x is equal 3.57. So x1 over here is 3.57. So t1. And t2 is 6.71. T2 over here is 6.71. Okay, so it says find determine the length of time. So length of time should be second quit, and 6.71 minus 3.57, so 2.84 hours in hours. So determine the length of time in hours. So it should be 2.84 Oh, I made a mistake. It's not this one, right? So it's 6.7, 6.7, not 4.1, 6.71 minus 3.57. So it's going to be 3.14. So 3.14 hours. This is second answer. Find the rate of change of the height when water, height of the water when t equals 13, giving your answer in meters per hour. Okay, when t equals 13, go to graph, find the rate of change of the height. So we need to find the rate of change of height. We need to differentiate the first function. So go to y3, math. We need to go to math and derivative of y2 function with respect to x. This is derivative of red function is purple function. So we need to find the value when t equals 13. So go to value of third function when t equals 13 over here. Enter. So it will give us dy dx. They give us a value of 0.65 minus. So rate of change equal minus 0.65 meters hour per hours negative 1 power. So we need to show the three significant figure actually. So and just see on the calculator is three significant figures minus 0.651 meters hour to the negative 1 power, hour meters per hour. Okay. On the same day, the height of water at the second island, Rockall, is modeled by function like this, where ABCD is some kind of a positive constant. The first low tide occur at 0241 when the height of water is 0.40. The first high tide occurs at time and height. Find the value of A, B, C, D. Okay, so this is to find the function. So let's see. What it says is first, this is also sinusoidal sine function like this. Let's say it's a kind of sine function from 0 to 2, 5. So we can draw something like a sinusoidal function, like nice and easy. And then first low tide. Oh, it starts from first low tide to first high tide. So we can pretty much draw like this. Doesn't matter, right? So first low tide over here occurs at 0241. Okay, 0241. Second quit. Okay, let's see. 0241 is 2 hours, and 41 is 41 divided by 6 is actually no. 41 divided by 60 is 0.68. So it's actually 0.02. So it's gonna be 2.68 hours. This first low tide. Height was 0.40 meters. And first high tide over here is 902. So 2 divided by 60 is 9.03. 9.03. When t equal 9.03, height was 2.74. Okay, it's meter. Find the value of ABCD. So A, so in this case, A is what? A is 2.74 minus 0.40 divided by 2. This is A. So 2.74 minus 0.40, entered everything divided by 2 is 1.17. 1.17 is A value. And D value, let's see D value. D value is arithmetic mean of 2.74 and 2.68, right? So 2.74 plus 2. What is 2 is coming from? No. 2.74 and 0.40. 0.40 divided by 2. 2.74 plus 0.4 divided by 2 is 1.57. So this is D value. And then we can find that period value of B. So 2 pi divided by B, this is the period. Period is from 2.74 to 2.68. So half period is 2.74 minus 2.68. What are you doing? This is the height. Don't confuse it height with time. So this is time, right? So 9.03 minus 2.68. This is a half period. times 2. So, right? So the full period is 2 times of half period. So this cancels out. So B is pi divided by 9.03 negative minus 2.68. So it's going to be B value will be 0.495. This is B. What is left? And then the leftover is C value, which is a positive integer. C value. Let's see C value. For sinusoidal function, C value, sine function start from here, right? So we need to find coordinate of here. So this coordinate over here is something right in between of 2.68 plus 9.03 divided by 2. So let's see, 2.68 plus 9.03 divided by 2. So C value is 5.855, so 5.86. C value is 5.86. Let's see, half period is about 7, a little bit less than 7 half period. C value is a horizontal shift from sine function. If C value is 5.86, it should be less than half period. Yeah, it is roughly less than half period, okay? So the function we have, so far we found out that h of t equals A is 1.17 sine value B is 0.495 parenthesis T minus C value is 5.86 close parenthesis twice plus D is 1.57. So let's see if this graph makes sense. So delete the first one, delete third one, and then by 3 I'm gonna put 1.17 sine of 0.495 open parenthesis x minus 5.86 close parenthesis twice plus 1.57 graph. So the first low tide is where? Here, where 2.688, and then first high tide is 9.03. Yeah, makes sense. And then this value is 2.74 and lowest value of 0.4 over here. See, come on, 0.4. Yeah, exact. Okay. So A, B, C, D, we found it out. The next question, when t equals large, t, the height of the water at the S island, same as the height of water at the R island, for the first time forever. So for the first time at t equals large, t, the height of both height are the same for the first time. So as you see, the first intersection of these two graphs happens over here. Yeah, this happens over here. So we find this value here. So x equals 4 point of when c, so x becomes 4.16. So large t equals 4.16 is the hour.